beautiful helmets to test. So we were charged with testing the effectiveness of an aero helmet with this similar design. And so initially we started out with a couple different tests. We did a roll test, just going downhill, and took the time and see if one was faster than a regular road helmet. We also tried some different lengths of just biking, cycling for 2 miles, 4 miles, maybe a little bit longer, to see if these helmets actually are more effective than a road.
Some of the difficulties we encountered in our tests were the wind and the weather. The wind affected the biker because it made it more difficult to ride at a constant speed due to gusts and even constant winds at different angles. The weather, such as rain or cloudy days, often made it difficult to test, especially when it was cold outside in the later months. It was also difficult to find riders in the community who were willing to participate with us and willing to test some of the helmets. We also had some environmental hazards, such as dogs, and speed bumps, and crashes, and different things like that, that made some of our tests difficult. Also, many of the people who did the tests were novice bikers. They had never done biking tests before, never run a time trial, and so that made it more difficult to find conclusive data.
Alright, so based on our previous results that Michael has already discussed, we decided that we needed some sort of easily repeatable loop of road that our cyclists could ride around. We decided on a 4-mile loop. We decided that distance simply because anything longer, the more laps and the more trials that a single cyclist would run, they would get tired faster, and that would mess with the data between different helmets. And anything shorter, we wouldn't get as consistent readings, as reliable data, simply because shorter distances mean shorter time, and therefore there wouldn't be as much of a discrepancy between the helmets. Essentially, the experimental procedure was fairly straightforward. All we requested of our cyclists was for them to choose one of the aero helmets, and as time went on, we would make sure that they were all measured or experimented with equally. But our cyclists would take the aero helmet and would ride the loop once, all the while trying to maintain constant velocity, because maintaining constant power is relatively difficult to maintain. And while I'm on that, one of the things that we used to maintain or to measure our power was a power tap meter that was installed in the rear tire, on the rear wheel, to measure power. And then once they were through with that run with the aero helmet, they would take one of the road helmets and repeat the exact same experiment, trying to maintain the same velocity that they had with the aero helmet. And once we were done, we would simply take all that data and compare the power output needed for that velocity. And so that's how we got our data, and then we took the data analysis from there.
In conclusion, I'd like to say that while we didn't get super clear data, we did get enough to establish a general trend that aero helmets have a slight advantage over road helmets. I would like to also express gratitude to our sponsors. First, the ones that donated helmets to us. Those would be Cask Helmets, Catlike, Rudy Project, UVEX, and Bell Helmets. I'd also like to express thanks to Bicycle City and Hub City for their assistance to us throughout the project. And also to John Cobb from Cobb Cycling, who gave us lots of helpful advice for this project. I would also like to thank all the bicyclists in the area who were willing to go out and run tests and let us use their